Hello and welcome to this lecture on interatomic bonding and material properties. So it is engineers need to know the attractions between the atoms because the properties of a material depends on these attractions between the atoms. So it is very important for a materials engineer or electronics engineer to understand these forces. So, material science it deals with the structure property correlation, like what is the structure of material and the property. Whereas for materials engineering, it is to design the structure of the material instead based on whatever the application it is. So, for a given application, we have to design the material to meet that application. So, the materials engineer has to develop that structure. Now, so whatever the material structure is there, the atoms and their interatomic forces, these are going to influence the properties of the material, like mechanical properties, electrical, thermal, magnetic, optical, and even deteriorative properties. So these are going to be affected by interatomic forces. Mm, Hence, so it is important for engineers or physicists to know about the interatomic bonding. Now, the interatomic bonding it is actually determined by the electronic structures of the individual atoms. So, a material has one type of element or multiple elements might be present. For example, in magnesium oxide, we have magnesium and oxide. So, in a magnesium oxide material, the interatomic bonding or interatomic forces, these depend on the electronic structure of magnesium as well as oxygen. In case if three elements are present, then it would depend on the electronic structure of three elements. Uh, so now, so the atoms, they achieve bonding how they achieve that by attaining stable configuration. So they do that either by receiving extra electrons or giving up electrons or sharing the electrons. So here, based on these, the bonds can be classified. So receiving extra electrons or giving up extra electrons. This happens in ionic bonds. So here, one and two will happen in the ionic bond, which is a primary bond. Whereas sharing of electrons happens in the covalent bond. Then the next one is the metallic bond. In this, the interatomic forces will be capable of holding the atoms together, and the free electrons will be no longer belong to a particular atom. So that is the valence electrons which are there. They will be moving around the entire. They belong to entire material. They are not restricted to one atom. They can move around the entire material. So the metallic bond is different in the perspective. So here we have primary bonds, which are three primary bonds. One is ionic bond, covalent bond, and metallic bond. Then we have secondary bond. Secondary bond is the van der Waals bond. This is weaker compared to primary bonds, but this is also important in understanding the properties of material. So what is valence electrons here? Valence electrons are nothing but the extra electrons uh, that are greater than the extra electrons compared to stable configuration. For example, chlorine atomic number we know that it is 17. So stable configuration is is up to 10 electrons or 10 electrons, and the additional 7 electrons are uh, the valence electrons. So for example, for sodium atomic number is 11, and stable configuration will be up to 10. Then additional one electron will be valence electron. So valence number of valence electrons of sodium will be 1. So valence electrons are important in understanding the properties of materials. So this is all about interatomic bonding and material properties. And here we have seen the classification of different bonds. In the next lecture, we will see, in the further lectures, we will see in detail about ionic bond, covalent bond, and metallic bond, as well as van der Waals bond. So thank you for watching this video, and please subscribe channel and write your questions in the comments.